set up so that I can see the chats. Hi everyone, welcome back. Welcome to Vedantu's JEE channel, everyone. Okay, so setup is done. Hi guys, how are you all? Okay. Hey everyone, welcome to Vedantu's JEE channel. And yes, I'm back. How are you all? How are you all? Who all are here, by the way? Nishant. Okay. Ashutosh is here. Ishwar. Bentley Williams, PKM, Archana, Pulkit, Vijay Lakshmi, Jatin, Nikita, Astha, Nishant, Alek, Balaji, Kalyan, Prahlad, Devil Gamer. Very nice. Everybody is here. Awesome. Awesome, guys. Awesome. Welcome. Okay, so weekend is over and weekdays have started. I know every day is same nowadays. Okay, let's just stay in the groove and still feel as if things are going as per the daily routine. Okay. If you want, you guys can share your daily routine on the chat box or not on the chat box, on the comment box after the session is done. Okay. I'm good, guys. I'm good. Thank you, Asta, for asking. I'm good. How are you all? Okay. Good to know that all of you are ready. For those who are here for the first time, this is me, your Suri Sir, also known as Mogambo. Yes, why do I call myself that? Is because when you crack this examination of JEE in future, yes, the examination will happen. Date got postponed, and now it is going to happen in the month of May towards the end. So when you will crack this examination, Mogambo khush hoga. Okay, guys. So how's quarantine? Well, I don't know about quarantine. I'm fine. I'm doing good. Okay. Mogambo is happy. Yes, I'm trying to cope up, trying to keep myself happy, and obviously, when all the live sessions happen, it feels very normal and the part of daily routine. That's good, and I hope that you all are also coping up well. Okay, good. I'm good, guys. I'm good. So let's start. So I hope that all of you are regular on Vedantu's JEE channel. If you are here for the first time, this is JEE Sprint going on, and now because your JEE examination has got postponed, so certainly we'll be doing a lot of things in the month of April as well. Okay, do watch all the videos which have happened already in the JEE Sprint series. This is probably the fifth session that I'm taking. Mechanics is done, magnetism is done, electrostatics, current, electricity, and we have done thermo, optics. Everything is done. Today we are. That's why we are on modern physics, which is obviously the last unit of physics that way. But don't worry, we'll continue the sessions. We will keep on coming back. Okay. So for those who are new or have been coming here regularly but haven't done yet, then do subscribe to the channel so that you are not missing out on things that we are going to do for you now from here onwards. Okay, cool, guys. Sprint 3.0 may happen. Yes, we are under planning of that also, so don't worry. Sprint 3.0. Cool, guys. So let's start. If you guys are ready, then just write yo or give me a thumbs up in the chat box, guys. If you are ready, please speak Marathi once. मला मराठी येत नाही. Awesome, awesome, awesome. Okay, Anirudh, welcome. Great, awesome. So I can see that everybody is ready, and let's start, guys. So the very first thing that we are going to cover in modern physics is obviously the dual nature of matter and radiation. Following the usual trend, first I'll share the important formula list with you all. Important formula I'll explain also, and then we'll get into the problem solving part of it. Okay, so this is your cheat sheet. You can call it a cheat sheet. Okay, so you know that when we are speaking about dual nature of matter and radiation, two most important parts which you cover here are photoelectric effect and the de Broglie's wavelength. Okay, so we know that for the photoelectric effect equation. Sir Albert Einstein got Nobel Prize as well for coming up with that discovery. Okay, so you know that whenever light is traveling, light as per the particle nature of light is made up of photons, and each photon has energy which is equal to h nu. So depending upon the frequency of wave which it is carrying, the photon energy, the packet of energy will also keep on varying. So it can either be written as E equal to h nu or E equal to hc by lambda, something that you guys know from your earlier standard itself. And if we want to find out the momentum of the photon, you can see that from here we will find it as h upon lambda, or lambda is h upon p. Okay, so E by C is also the way to calculate the momentum of photon. So you know that why we are not writing it as m into v is because photon is not a particle which has mass, so it is more of a broader envelope understanding of energy. So that's why there is no mass involved. So you cannot write the momentum of a photon as mass into velocity. So rather we write it as h upon lambda. Okay. So now we know that whenever there is a certain light of certain frequency, certain wavelength falling on a metal surface, then if the light is energetic enough, when I say energetic enough, it has a certain maximum, certain minimum frequency, certain maximum wavelength, which we call as the threshold wavelength or threshold frequency. So if the light of sufficient frequency falls on a metal surface, then because of the falling of that light, the electrons are ejected out of that metal surface, which we call as the phenomena of photoelectric effect. So the maximum kinetic energy electrons which come out, not all the electrons come out with maximum kinetic energy, but the electrons which come out with maximum kinetic energy, that kinetic energy is calculated as h nu minus phi. Now what is h nu? H nu is the energy of the light which is falling on the metal surface. And what is phi, guys? Phi is basically your work function. What is work function? Work function is basically what defines the threshold energy which it requires to bring the metal electrons to the surface. So this is the minimum amount of energy that you must make the electron receive so as to just reach the surface. And if h nu is just equal to phi, then obviously the maximum kinetic energy will be zero. So if you want the electrons to come out with some energy more than zero, obviously, then yes, the energy of the light which is falling must be greater than the work function. If it is less, then obviously nothing is going to happen. Okay, so how do you calculate the threshold frequency? You can see that as work function is h nu naught, so nu naught comes out to be phi by h. Perfect. Okay, similarly, if the electrons are coming out with some kinetic energy and you want to stop it by applying a electric field in such a way that you can repel it, then that electric field will have its own stopping potential, that is E into V naught. Okay, the amount of work which is done to stop the electron is Q into V naught. So this stopping potential is equal to actually the maximum kinetic energy. Okay, so that is why you can see that it's the same equation, hc by lambda minus work function into ev naught. Okay, you can write an equation before that, that is ev naught equal to hc by lambda minus work function, and this is h nu, which is hc by lambda. So you're just dividing it by the charge of electron and you are getting the potential value, which we call as the stopping potential. And the graph for the same has also been drawn here. Okay, so what is work function? Again repeating, work function is the minimum amount of energy required by the electrons inside a metal surface so as to come out of the metal surface when they receive that much amount of energy. Okay, and similarly, de Broglie wavelength formula we all are aware about, h upon mv. This is applicable for things which have mass. Okay. So cool, guys, let's go to our very first question here. Question says that work function of lithium and copper are respectively 2.3 electron volts and 4 electron volts. That's the unit of energy. Okay, that's basically joule divided by the value of charge. That's what makes it electron volt. So which of these will be used for a photoelectric cell that works with visible light? So we know that visible light has a wavelength range from 4000 angstrom to 7000 angstrom. Okay, so which of these has their threshold wavelength in this range? If the threshold wavelength is in this range, then the material will be used for the photoelectric cell, else it will not be. Okay, so people are saying option A, that is lithium. So let's see, let's try to find the answer to this one, guys. Okay, so we know that threshold wavelength can be calculated as Hc by E, so the amount of energy which is required here. And because we are speaking about the threshold case, so it will be work function phi. Okay, and we know that if we use the value of H into C and divide it by the value of E here, okay, why? Just to convert it into the electron volt formula. So that comes out to be 12430 by the work function. So if we calculate the value of threshold wavelength for lithium, then that value will be 12430 divided by the work function for lithium, and that is given to us as 2.3. Okay. Similarly, if you do the same for copper, it will be 12430, and that value for work function is given as 4. So when you simplify this, this value comes out to be close to 4380 angstrom, and this one comes out to be 3094 angstrom. Okay, and we know that the threshold wavelength should be less than or equal to 7000 angstrom, or should be greater or equal to 4000 angstrom. And in this case, what you see, the only wavelength which is lying here is of the threshold wavelength is only for lithium, not for copper. That's why the correct answer will come out to be option A. You guys are right. Right. The answer is lithium. Very nice, guys. Very nice. Keep it up. Okay, Blitz Dragon, welcome. Welcome. Let's move on to the next one, guys. Now, this one says a particle A of mass m, initial velocity is v, it collides with a particle B of mass m by 2, which is at rest. And the collision which is happening is head-on and elastic. The ratio of the de Broglie wavelength of lambda A to lambda B after the collision is going to be how much? So we know that de Broglie wavelength is h upon mv. So what is happening here? We have two particles. One of them has mass m and a velocity v. The other one has mass m by 2 but initially at rest. So when they collide, after that they both have their individual velocities. Say this mass m has a velocity v1 and the mass m by 2 has a velocity v2. So we have to find out the value of lambda a by lambda b, which is going to be equal to inverse ratio of momentum. So that's why it will be mb vb divided by ma va. So for that we obviously require the value of v1 and v2. So let's use our understanding and concepts of collision, elastic collision, and let's try to find this out. So guys, in this case, drawing it again, the velocity is given as v for the first particle. Second particle is at rest. After collision, this mass m moves with a velocity say va, and this one particle m by 2 moves with say velocity vb. Okay, so now we know that according to the law of conservation of momentum here, the initial momentum m into v should be equal to m into va plus m by 2 into vb, which gives me the value as v equal to va plus vb by 2. Okay, apart from that we know that the velocity of separation should be equal to velocity of approach, or velocity of approach should be equal to velocity of separation. So velocity of approach is basically v minus 0 and velocity of separation will be vb minus va. Okay, so if we just add these two equations, because we are interested in finding the value of vb and va, you can see that va and va get cancelled and this comes out to be 2v equal to vb plus vb by 2, that is 3vb by 2. From here we get the value of vb as 4v by 3. Okay, and if we put this value say in this one, then vb is known, so va comes out to be vb minus v, which is 4v by 3 minus v. So va will come out to be v by 3. Okay guys, yep. So now we can find out the value of lambda a by lambda b. That's the ratio that we are interested in finding. So that is m b vb divided by ma va. So mb is m by 2, vb is 4v by 3 divided by m into v by 3. So from here, m gets cancelled, v by 3 gets cancelled, 4 by 2 gives me the value as 2 is to 1. Okay, so the answer comes out to be 2 is to 1. Very well done, guys. Awesome. Awesome. Yes, correct answer is option A. That's great. Good job, guys. Good job. Very well done. Very well done. Let's move to the next one. Okay. Next one. The kinetic energy of the particle, this is not or but of the particle is E and its de Broglie wavelength is lambda. So on increasing its kinetic energy by delta E, its new de Broglie wavelength becomes lambda by 2. Okay, so we have to find out the value of the amount of energy that you are increasing. Okay, we know that lambda is equal to h upon mv, and this mv can be written as under root of 2 me. Okay, under root of 2 me, that's the relation between momentum and kinetic energy. So we can say that this lambda is inversely proportional to this energy. Okay, guys, so initially the lambda value is lambda, then it becomes lambda by 2 if the energy which was earlier as E final, and later this lambda is related to E initial, and inversely this will be E final in under root. Okay, guys, so if you cancel this ratio looks like it is going to be 2. So E final by E initial is equal to 4, or we can say that E final is equal to 4 times of E initial. So if your E initial is E, then E final is 4 times E. Okay. So what you people are getting your answer as? Okay. People are saying answer is option D, but we have to find out delta E. Delta E is basically E final minus E initial. Okay. That means 4E minus E. So the correct answer is 3E. That is option A. Okay. Such a mixed review this time. Come on, guys, read the question along with me properly. Okay. Okay. That's nice. Yes, much better. Awesome, guys. So next one. How about this one, people? Look at this. Okay. Okay. So now this one says that an electron is accelerated by a potential difference V to hit a metallic target to produce X-rays. It produces continuous as well as characteristics X-rays. So if lambda minimum is the smallest possible wavelength of X-ray in the spectrum, that means we are talking about the threshold wavelength. So the variation of log lambda minimum with log V is correctly represented in which of these? So guys, we know that lambda minimum will be written as hc by the kinetic energy E, and energy we can write as E into the stopping potential or the voltage with which you are accelerating it in this case. Okay, guys, so that is your lambda minimum. So let's do one thing. Let's just take log on both the sides. So if I take that, I have log lambda because I have to separate log V. So on this side, I will take log HC by E, which we know is a constant, minus of log V. Why? Because it's in denominator. So that's why minus of log V is what we are getting. So if you want, you can compare it with Y equal to C minus X, or you can say it is minus X plus C, which looks like a straight line with a negative slope. So if the negative slope line we have to look, the only option that we see here is option D, not C, but option D, guys, because the equation that we are getting, it's an equation of a straight line with the negative slope and positive intercept. So this is a positive intercept and negative slope. Okay, great, guys, awesome, very well. Okay, next one, guys. So in this one, what we are getting is an electron of mass m, and a photon have the same energy E. So an electron of mass m and a photon or have the same energy E, and the range of few electron volt is being mentioned there. So the ratio of de Broglie wavelength associated with the electron and the wavelength of the photon is, okay, the ratio of the de Broglie wavelength associated with the electron and to that of photon. So हमें basically lambda E by lambda P पता लगाना है. So lambda E by lambda P is to be found. We know that for electron we will use as de Broglie wavelength. So H upon mv, which we can say is H upon 2me in under root. Okay. While for photon you will write it as H upon hc by E. So that's basically the energy here. So let's just take the ratio lambda E by lambda P is basically H upon 2me in under root into E by hc. So H gets cancelled, and what do I see here? So I have 1 upon C out, and if I take this in ratio in under root, then this value will be root E by 2m. So 1 upon C under root E by 2m is what we are getting. So certainly answer is option D. Not C, option D it is. Because this part, if you will see, you have E divided by root E, which you can write as E square by E in under root, which makes it under root of E. That is why this root E in the numerator. Okay. Awesome. Very well. Next one, guys. Next one. So in a photoelectric experiment, the wavelength of the light incident on the metal is changed from 300 to 400 nanometer. Remember, because the energy is hc by lambda, so if you are increasing the wavelength, the value of energy with which the light is falling is decreasing when the wavelength is increasing. So that is why the kinetic energy with which the electrons will come out will also decrease. So that is why the question is asking the decrease in the stopping potential is close to how much now? Because what has happened? The kinetic energy with which the electrons are coming out from the metal surface, that is less, so you require a lesser amount of work to be done to stop them. Okay, so let's try to simplify this one. Okay, so guys, if we say by Einstein's photoelectric equation, the kinetic energy with which you want the electrons to come out is going to be equal to the stopping potential. So EV1 is equal to hc by lambda 1 plus work function. This is basically the stopping potential into the value of E multiplied there, so that it is equal to the maximum kinetic energy. Okay. Similarly, EV2 is equal to hc by lambda 2 plus work function. So we have been given the values of lambda 1 and lambda 2. Let's take the difference of both of them. So EV1 is more, obviously. Earlier it was more. If I take the subtraction of these two, I have hc by lambda 1 minus hc by lambda 2. Okay. So V1 minus V2, which we are interested in finding, is hc by E 1 upon lambda 1 minus 1 upon lambda 2. So this value hc by E has been mentioned as 1240. So 1240, and this is 1 upon 300 minus 1 upon 400. So you can see that it is 1240 into 400 minus 300, that is 100, divided by 12, 1, 2, 3, 4 zeros. So these three zeros get cancelled with 1, 2, 3, 0. What you are getting is 124 by 120, which is nearly equal to 1 volt. Yes or no? The difference is almost equal to 1 volt here. The correct answer is option C. Awesome. Yes, the correct answer is option C, everyone. I hope you are able to understand this. Okay. Very nice. Good, good, good. So what we did, we just took the value of stopping potentials, the difference of those, because the work function is same in both the cases. It's the same metal surface, so work function gets cancelled here, and the answer came out to be eventually almost equal to 1 volt. So when the wavelength got dropped from increased from 300 to 400 nanometer, then the stopping potential value got dropped by 1 volt. Okay. Okay. Next one looks like similar to the previous one. So the surface of certain metal is first illuminated with the light of wavelength 350 nanometer and then by the light of 540 nanometer. So again you are increasing the wavelength. So obviously the energy with which the electrons come out will decrease. So it is found that the maximum speed of the photoelectrons in the two cases differ by the factor of 2. Obviously here if the, or say in the second case, if the speed with which electron comes out is v, so here it has to be double, because earlier the wavelength was less, frequency was more, so the electrons got more energy to come out. Later on you decrease the wavelength, so obviously the energy with which electrons are coming out is going to be less. Okay, so in the two cases the difference of the speed ratio is being mentioned, the factor is given. So if this is v, this is equal to 2v. So the work function of the metal has to be found here. So what has been given is that energy of photon can be written as 1240 by lambda. Okay guys, looks very easily doable to us. Wavelengths are 350 and 540. So earlier if I write hc by lambda, the energy which you are giving is hc by lambda 1 minus work function, and this is equal to half m v1 square. So this value is hc by 350 minus work function, and this is equal to half m into 2v square. Okay, yeah. So this value comes out to be half m 4v square for us. Okay, I hope that's visible. In the next case, similarly, it becomes hc by 540 minus the work function, and that value is half m v square only. Okay, so if I take the value here and if we just take the ratio of these two, then what will happen here? If we just divide these two guys, on dividing it we are getting hc by 350 minus work function divided by hc by 540 minus work function. This ratio should come out to be 4. So you will take it here. So hc by 350 minus work function is equal to 4 hc by 540 minus 4 phi. So effectively when you take it here and you bring these values here, you have 3 phi equal to 4 hc by 540 minus hc by 350. Okay. So guys, when we simplify this value, obviously we'll require a value of hc to be put here. So if I say that phi will be equal to 1 by 3, hc if I take out, that is 1240, I guess, 1240, yes, that value is hc, and multiplied by 4 by 540 minus 1 upon 350. So I'm leaving this calculation for you guys to do here. Okay, yep, approximately when you will simplify this value guys, this value comes out to be close to 1.8. Okay, that is the value that we will be getting it here. Please try that at home after the session. The value comes out to be 1.8 electron volt. Yep, the correct answer is option A. 1.78 something this value comes, so nearly on rounding off it is 1.8. Okay, okay guys, next one. A metal plate of area 10 to the power minus 4 meter square is illuminated by the radiation of intensity 1.6 milliwatt per meter square. Okay, so intensity has been given. We know that intensity is energy falling per unit area per unit time, or you can say it is power per unit area. Okay, so the work function of the metal is 5 electron volt. The energy of the incident photon is 10 electron volt, and only 10% of it is produces the photoelectron. Okay, So the number of emitted photoelectrons per second and their maximum energy is to be found. Okay, so what is given to us? We have been indirectly given the value of the energy here, because we have been given the value of area and the power, the intensity here. So we can calculate the value of power very easily. Work function is given and the energy of 10 electron volt is falling here. So let's try to find out, guys. So if we try to find out the energy incident per second, that means if we want to find out the value of E by T here, which is going to be intensity into area, that value of intensity is given to us as 1.6 into 10 to the power minus 3 into 10 to the power minus 4. That value comes out to be 1.6 into 10 to the power minus 7 watts. So this is the amount of power with which the energy is falling here. Okay, guys. Now if we try to find out the value of the maximum kinetic energy, which is basically is h nu minus the work function. So the energy which is falling is 10 and the work function is 5. That value comes out to be 5 electron volt. So you will not take the 10% of this value right away, because if you will take the right 10% of this right away, that will be 1 electron volt only. And if I put here as 1 electron volt, then 1 minus 5 will not even make an electron come out of it. Okay, so understand that effectively whatever is the kinetic energy with which electrons can come out, so the total count, whatever ideally it should release that many number of electrons, only 1/10 of that will come out of the metal surface. Okay, so now what is happening, guys, here? So if we look at the total number of electrons here, so the total energy with which the electrons are coming out, the power is already being known to us, which is basically here. So if we want to find out the total number of electrons, the total amount of energy with which the electrons are coming out, that is basically, this is the energy of electrons per second. So total number of electrons, the energy with which they are coming out, hc by lambda, is basically 1.6 into 10 to the power minus 7. This n is number of electrons per second. Okay, so this small n is basically the total number of electrons coming out per second here. So if I calculate the value of n from here, then n will be equal to 1.6 into 10 to the power minus 7 divided by hc by lambda. Yes or no? The total amount of energy which is taken by a single electron here. So 1.6 into 10 to the power minus 7 divided by the value of this value is basically, if we look at here, the 10% of this energy is going to be the energy hc by lambda. That comes out to be 10 into 1.6 into 10 to the power minus 19. So when we simplify this, guys, the total number of electrons that are coming comes out to be 10 to the power 11 per second. This many number of electrons are coming out. Okay, yep. So out of this, only 10% of electrons are coming out of it. So 10 to the power 11 into 10% gives you the value as 10 to the power 10 number of electrons emitted per second, and that's what we were required to find, the total number of emitted photoelectrons per second and their maximum energy. So we found the maximum energy already here. Maximum energy with which the electrons are coming out is 5 electron volt. Okay, this value which was given to us, hc by lambda, is already given to us as 10. So we put that value as 10 and also divided that, multiplied that value by E value, so that we convert it into joules. Okay, so what we did, we first of all found that how much amount of energy is falling on the surface per second. ये per second कितना energy surface को मिल रहा है, 1.6 into 10 to the power minus 7, because this is the energy which is going to release the overall electrons out of it. Okay, that is what has been given. Okay, so this is what we will be using eventually, but what is given to us, that what is the energy with which the frequency and the wavelength, according to that how much amount of energy of incident photons is there. So photons have the energy of 10 electron volt, work function is 5, तो इलेक्ट्रॉन्स जो बाहर आने वाले हैं गाइस, वो कितनी एनर्जी से बाहर आएंगे? 5 इलेक्ट्रॉन वोल्ट. सो एज पर द ऑप्शन ईदर बी, सी और डी इज गोइंग टू बी द आंसर. ए कैन नॉट बी द आंसर. But if we want to find out the total number of electrons, this is the energy with which we are illuminating the surface, and each number of electron per second that is falling, the number of electrons which are following, each are having the energy of 10 electron volt. Okay, so multiply this value by the value of charge, you will be getting the value of the energy in joules. So this is the total energy that is falling per second. The energy of each and every photon, multiply that by the value of E so that you get it into joules. Simplify this, we get the total number of electrons coming out as 10 to the power 11 in an ideal scenario. But question says that only 10% of the electrons are able to actually come out. So of this, the 10% value is 10 to the power 10. Okay. No, it's not a recording, it's live session. Okay. Okay. Next one, guys. In this one, we have a particle A of mass m and charge q, which is accelerated by a potential difference of 50 volts. Okay. So another particle is also there whose mass is 4 times, charge is same, they both have the same charge, and is accelerated by a potential difference of much more, almost 50 times of that potential. So the ratio of de Broglie wavelength is close to how much? So we know that lambda is basically h upon mv, and that can also be written as h upon 2me, and this energy can be written in terms of stopping potential as h upon 2m q into v. The energy is basically E into v or q into v. That's basically the amount of work done to stop the electrons which are coming out usually, or any material in this case. So if we have the ratio here, we can find out the value of lambda A by lambda B as under root of MB QB into VB divided by MA QA VA. What they have same in the formula is 2 and H only. So let's put the values here, guys. Okay, mass for the second particle is 4m, charge is q, and I think this will not be visible, so let me write it here. It will be 4m into q into 2500 of potential difference. The first particle has a mass m, charge is also q, but the potential is 50, and this everything is in under root. So m gets cancelled, q gets cancelled, this is 50 times multiplied here. So you have under root of 200 coming out here, which is basically 10 root 2. You know that root 2 value is 1.4, so close to 14 is what you are going to get here. So the nearest option is option C. Okay, easy it is. Okay, very nice, very nice. Very good, guys, very good. Yes, correct answer is option C. Okay, let's move on to the next part of modern physics. This was dual nature of matter and radiation. Now we'll be speaking about the atomic structure. You know that in atomic structure, we studied this much more in detail in chemistry as well, where we speak about J.J. Thomson's plum pudding model. You must have studied the Rutherford's alpha scattering experiment, but effectively where the overall story ends, or currently what is going on, is the Neil Bohr's atomic model. So these are the things that we study. Okay, and I'm sure that you guys, because it is also, it overlaps with chemistry, so many students find it very easy. Okay, so try to solve questions along with me. These are the formulas. I am hoping you guys are aware about these formulae. If you are not, then keep them in mind. The energy of nth orbit is very important. 113.6 z square by n square electron volt. The Bohr's orbit, which you can find very easily by equating the electrostatic force with the centripetal force, that is mv square by r. Okay. Hmm? Similarly, whenever the electron makes a transition from one orbit to another one, if it is coming from higher to lower energy level, then obviously it emits a radiation, and the photon has the energy and the wavelength as 1 upon lambda. Okay, guys, take a screenshot, everyone. Okay, so let's go now. Let's do the problem solving, which is our usual routine here. Okay, people. So what you see here, that hydrogen, deuterium, singly ionized helium and doubly ionized helium, all of them have single electron. So it's a uni-electron model, as we all know. And considering that electron transition is happening from n equal to 2 to n equal to 1, that means some photon is going to be released. So if the wavelength of emitted radiations are lambda 1, lambda 2, lambda 3, lambda 4, then respectively for 4 elements, the ratio or the approach says that which one of the options is going to be right. Okay. So we know that as per this formula only, the last one that you see here, that 1 upon lambda is rz square 1 upon n1 square, which is 1 square divided minus 1 upon 2 square. So here you can see that this factor is same for every element which has been mentioned here. R is same. So I can say that 1 upon z is proportional to z square, or z is proportional to 1 upon, sorry, lambda is proportional to 1 upon z square. Okay, so we can say that lambda 1 is to lambda 2 is to lambda 3 is to lambda 4 will be equal to, first thing is hydrogen, so 1 upon 1 square is to 1 upon again deuterium is also the same atomic number, so that is also same. Okay, is to, third is helium, so 1 upon 2 square, and fourth is lithium, so 1 upon 3 square. So what we are getting is 1 is to 1 is to 1 by 4 is to 1 by 9. So if we write this here, okay, so as per this, if we go, guys, this is telling us that 1 upon z square is what has been taken. So if we try to take the ratio here, then the value will satisfy, as you can see here, the value will look like to be satisfying option C. Yes or no? Okay, as per the ratio, if we go, it's lambda 1 equal to lambda 2. That's only one option where lambda 1 and lambda 2 are equal, by the way. Okay, easy one. Awesome. Now the next one. So the radiation corresponding to 3 to 2, that means we are going from second excited state to the first excited state. Yep. So transition of hydrogen atom falls on a metal surface of to produce photoelectrons. So basically, when in the hydrogen atom, an electron is going from second excited state to first excited state, some energy in the form of electromagnetic radiation is being ejected, so that energy is incident on a metal surface so as to make the photoelectric emission phenomena happen, and the electrons are made to enter into a magnetic field 3 into 10 to the power minus 4. Okay, third aspect has been added. So if the radius of the largest circular path followed by these electrons is this much, then the work function of the metal is close to. So basically, three chapters are clubbed together in this question. First one is obviously the atomic structure, second one is your photoelectric effect, and third one is your a charged particle moving in a circular path. Okay, guys, so looks like a very interesting question. So first of all, let's find out that what is the energy with which your electron is coming out. Okay, the electron is going to come out. We know that the value of energy with which the electron is coming out is calculated as 13.6 z square by n square with a minus sign here. This is the energy of the electron in a orbit. So if you want to find out the difference of the energies in the transition, then it is 13.6 z square is 1. So 1 upon 3 square, okay, sorry, 1 upon 2 square, because I have taken minus into a consideration. minus 1 upon 3 square. So guys, when we do this, this is 13.6. So this is 5 by 36. So when you simplify this, value will close to 1.9 electron volt. This value comes out to be. Okay. Yep. Which is equal to the energy of the photon with which it is coming out, that is h nu or hc by lambda. Now, also we know that the radius of the orbit for a charged particle in a magnetic field is given by what? Yeah, this is the question. If you have not read the question, read the question. Okay, so from here, guys, if we, because we want to write down the maximum kinetic energy of the electron, because the energy is falling and we are interested in finding the work function. So obviously we'll require the kinetic energy. For that, what I'm doing to make it mv square, I'm squaring this whole side. So r square is equal to m square v square by q square v square. So what do I have? Okay, I have q square v square r square equal to m square v square. Okay. Okay. So now what if we write the maximum kinetic energy, K max? That's basically the energy with which your electrons are moving. So that is basically half mv square. We already have the value of m square v square here. So I'm doing one thing. I'm multiplying it by 2, multiplying it by m, dividing it by m. So I have mv or m square v square by 2m, and that value m square v square is q square v square r square, q square v square b square and r square divided by 2m. That's basically the energy with which your electron came out of the metal surface. That's what we need, and we already have the value of the incident energy. Okay, so from here now we can go and talk about the photoelectric equation, which is basically the energy which you are incidenting minus the work function. So h nu minus the work function should be equal to the maximum kinetic energy. So this energy is 1.89, work function is unknown, and if we write this value, so this value is going to be, say, charge of electron, that is E square into B square, okay, and R square divided by 2m. And if I want to convert it into electron volts, then because these values are electron volts, guys, so you will have to take care of this one E as well. So just taking care of that E, okay, converted it into electron volts here. So now, guys, this value is 1.6 into 10 to the power minus 19. The value of B has been given as 3 into 10 to the power minus 4, and you will have to square it. Radius value has been given as 10 millimeters. So that is 10 into 10 to the power minus 3. You will have to square that as well. Divide that by the mass of the electron, that is 9.1 into 10 to the power minus 31. Okay, so when you simplify this factor, guys, this comes out to be 1.89 minus 5 equal to 0.79. On simplifying, leaving this part as the calculation for all of you to try, okay, the value of phi here come out to be 1.1 electron volt. Okay, this is the part that I want you people to try. EB square R square by 2m. EB square R square by 2m. From here you will be able to see the value also. Charge of electron 1.6 into 10 to the power minus 19. B value is 3 into 10 to the power minus 4. Square that value. R is 10 millimeters. So 10 into 10 to the power minus 3. Square that as well. And divided by 2 into 9.1 into 10 to the power minus 31. So when you simplify this, should come out to be 0.79. Okay. Yeah. So the correct answer that we get is 1.1. That is option B. I know, little lengthy, not a very competitive examination type of question, but we are solving majority of questions which makes our understanding clear with multiple concept involving questions. Okay. Now next one, guys, the time period of revolution of electron in its ground state in a hydrogen atom is given to us. So the frequency of revolution of the electron in its first excited state. So that means the first case is when n is equal to 1 and then n equal to 2 ho jayega. So we have to find out the value of the frequency here. So guys, in order to find that, first of all, the formula for time period is h cube by 4 pi square k square e to the power 4m into n cube by z square. But what matters here right now as per the question is T is proportional to n cube by z square. And which element we are talking about? It's basically hydrogen. So this value is any which way 1 and same. So we can say that T2 by T1 is equal to N2 by N1 the cube. Okay. So N2 is basically 2 and this is 1. You are cubing it and this value is 8. So basically T2 is 8 times of T1 and what we have is the time period of revolution of electron in the first ground state is basically 1.6 into 10 to the power minus 16, multiply that by 8. So this value comes out to be 12.8 into 10 to the power minus 6. Okay, minus 16 it is. So this is minus 16 seconds. Okay, so we have T2. So frequency is going to be 1 upon T2. So that is okay. So 1 upon 12.8 into 10 to the power 16, or you can say it is 100 by 12.8 into 10 to the power 14. So answer is of the order of 10 to the power 14. So we have two options in that order. So obviously 1.6 cannot be the answer here. Answer comes out to be 7.8 into 10 to the power 14 hertz. Okay, got it guys? Awesome. Yes, the correct answer is option C. Okay guys? Yes, correct answer. We got it. Next one. A hydrogen atom initially in the ground state is excited by absorbing a photon of wavelength 980 angstrom. And the radius of the atom in the excited state in terms of Bohr or Bohr radius is to be found here. Hc का value हमें दिया हुआ है guys. It is 12,500 electron volt into angstrom. Okay. So we are being asked to find out the value of the radius of the atom when the atom which was initially in the ground state is excited and has gone to a next excited state. Okay, so we need to find out which excited state it actually has gone to. Okay, so if we look at delta E, that value should be equal to hc by lambda, the amount of energy which it is actually going to gain here. Okay, so that value is basically 12,500 by lambda. And if we want to find the amount of energy, this is the falling energy, and if we want to find out the amount of energy which is utilized, it is 13.6, 1 upon 1 square minus 1 upon n square, and this should be equal to 12,500 by lambda. This is the amount of energy falling and this is how it has been utilized by the atom. Okay, so lambda value has been also given to us, so I can say that it is 1 minus 1 upon n square equal to 12,500, okay, divided by 13.6, and lambda value is 980. That has been given in angstrom already. So guys, when we simplify this value on simplification, 1 upon n square, which is equal to 1 minus 12,500 by 13.6 into 980, this value comes out to be 1 by 16, which gives you the value of n as 4. So as per the understanding of Bohr's atomic model, the radius of excited state is n square the Bohr's radius. So in that case, this value is going to be 16 A naught. Okay. Yep. Means correct answer is option D. Okay. Next one, guys. The energy required to ionize a hydrogen like ion in its ground state is 9 Rydbergs. Okay, so 9R is the energy. So what is the wavelength? Basically, what we do not know is what is the atomic number of the element whose ion has been given. and the wavelength of the radiation emitted when the electron in this ion jumps from second excited statement means n equal to 3 to the ground state, that means n equal to 1. So question समझ लेते हैं. Energy required to ionize some element whose atomic number is not known but it's a unielectron ion is 9 Rydberg, and we are being asked that what is the wavelength of the radiation which will emit in this ion when the electron in this ion will jump from n equal to 3 to n equal to 1. Okay, so let's try to simplify this. We know that the amount of energy which it is going to release, that is hc by lambda, is basically 13.6 z square 1 upon n1 square minus 1 upon n2 square. Okay, so here if we are putting up the value here, so n1 value is 1, n2 is 3. So this value has been given to us as r, or we can just say that if n1 is 1, then hc by lambda I can write it as 13.6 into 1 upon 1 square minus 1 upon 3 square, and this is z square. Now what is given to us is that the value of rz square is 9. So if this value is it is given as 9r, the amount of energy which it is requiring. So this is only possible when z value is equal to 3. Okay, hydrogen, helium, lithium. Lithium is basically that element. So I can put the value of z as 3 here now. So 13.6 into 3 square, that is 9, and when we simplify this, this comes out to be 8 by 9. So when we cancel this value, we get the value of hc by lambda as 13.6 into 8. So if we want to find out the value of lambda, that is hc divided by 13.6 into 8 here. Okay, so hc ka value in nanometer is 1240. Divide this value by 13.6 into 8. So when we simplify this, guys, lambda nearly comes out to be 11.4 nanometer. Yep. Okay. Do these calculations, guys. After the session, you can try these calculations. The value roughly will come out to be 11.4. Okay. The answer is option B. Okay. Okay, no problem. There are people who are still joining. Okay, welcome. We are in the middle of the session. So guys, if you are with Vedantu and you want to continue your preparation at even more serious level, because you know that your JEE examination has got postponed till May 2020 end. May end of 2020, this examination is not happening before that. So you can continue your preparation with our crash course, where you are getting 45 live classes, 35 tests are still there. Okay, doubt solving sessions, you can watch the replays and recordings of each and every session of each and every topic of each and every subject here. Okay, and yes, you get a lot more things, important tips and tricks to crack JEE, rank booster quizzes and previous paper analysis. If you are interested, then all you have to do is go on this link, use this coupon code, because the course which is worth rupees 30,000 becomes yours for just 2,900. Okay, these are the steps you have to follow. This link is available in the description of this video down there. All you have to do is click on enroll now. Don't forget to use the coupon code, that is SMCC, and yes, you will be the part of the Vedantu's platform then. Okay guys, next one. Now the next part of modern physics is the nuclear physics, a very interesting chapter I think, because it involves first order kinetics that you study in chemistry. Okay, important formulae, the nuclear radius, you should know that the atomic radius is of the order of 10 to the power minus 12 picometers, while the nuclear radii is of the order of Fermi, that is 10 to the power minus 15. So that's why the formula is very important here. Similarly, the first order kinetics of radioactive decay, the activity is proportional to the activity constant. So dN by dt is equal to minus lambda n. The activity is proportional to the number of elements which are undecayed, number of nuclei which are undecayed. So if you simplify this, integrate this, the equation looks like this. Okay. Yeah. And one more very important formula is this one. you can also convert this formula as n by n naught equal to 1 upon 2 to the power t by t half. Okay, this is also very important formula to calculate the value of t or t half. Okay, the value of half-life is ln by lambda. Mass defect, as you know, the actual mass of the nucleons, means the total number of protons and neutrons. If you take their total mass, and if you will look at the mass of the atom or the nuclei in that case, there is always a difference in the value which is expected and value which is actually there, which we call as the mass defect. Okay, to calculate the binding energy, you can multiply that by c square. You will get the value of binding energy here. Okay, similarly, in the case of a nuclear reaction, the mass of reactants is always more than the mass of the products. Okay, just a minute, guys. Yep, cool. These are the important formulae for the nuclear physics part. Let's start the problem solving. So, radioactive nucleus A with half-life T decays into nucleus B. Okay, so A is converting to B by radiating radiations, and there is no nucleus B at T equal to 0. So at T equal to 0, it's purely the nucleus of material A, and after some time the ratio of the number of nuclei of B to that of A, means NB by NA, is equal to 0.3, or you can say 3 by 10. Then T is given by how much? So after how much time this ratio is going to be there, that's what we have to find out. Okay, so what is given to us is NB by NA, which is equal to 3 by 10. Okay, guys, that means what if I take it as face value that NB is equal to 3, Na is equal to 10, then total number of nuclei which are there or which were there always at T equal to 0, let's call it N0, is equal to 3 plus 10. That means 13. Okay, so if I speak with respect to A, so we can say that if N is equal to N naught e to the power minus lambda T, then N value is basically how much? N value now has become 10. This is, I'm writing for A. So this is 10, this is 13, this is e to the power minus lambda into T. Okay, so I can say that it is 10 by 13, which is equal to e to the power minus lambda T. So if I write it as say, if I take the log here, guys, so I can say that it is 13 by 10, which is equal to e to the power lambda T, or we can say that this value is 1.3 also. So lambda T is equal to ln 1.3. And what is lambda? Lambda is ln 2 by T half into T. T half they are writing as capital T. Okay, just a minute. I hope you guys are trying to solve this along with me. Huh? So this is ln 1.3. So T value comes out to be T ln 1.3 divided by ln 2 is what we are getting here as the answer, which as per the option looks like option A, because here it is only 1.3, it is in denominator. So yes, the correct answer is option A. Okay, what we did, we just took this ratio on the face value and we assumed that the total number of nuclei were 13, or this will always work for any ratio, by the way. Okay, for any number the ratio will always work this way. Now tell me this one, guys, in the chat box quickly, what do you think is the answer? In a gamma ray radiation from the nucleus, only the proton number changes, both the neutron number and proton number changes. There is no change in the proton and neutron number, or only the neutron number changes. What do you think, guys, is the correct answer to this one? What happens during a gamma decay? Come on, guys. The answer to this question, the present one on the screen. Can you tell me? Exactly. You know that for alpha particle, which is 2 4 He by 2, there is always going to be change in proton and neutron. For beta particle, which is nothing but an electron, it is going to be 0 1 e 1 e 0. It is going to be okay. Sorry, यहाँ 0, यहाँ पे -1. Okay, and for gamma, gamma is basically 0 e 0. Nothing, no changes will happen when a gamma radiation is being taken out. No change in the mass number or atomic number. Perfect, guys. So based upon that only, tell me this: which of the following process represents the gamma decay? If you have understood that part, tell me which of these do you think is representing the gamma decay? Reaction A, B, C, or D? Tell me, guys. Awesome. Yes. Now you guys are able to understand that here Z has decreased, here A has decreased, and here also the value of Z has decreased. The only equation where the reactant and the products have the same atomic and mass number is option C. Very good. Yes, correct. Answer is option C. Very well done, guys. Awesome. Now this one. Radioactivity questions are very interesting and easy. So the radioactive material X1 and X2 have decay constant as 10 lambda and lambda respectively. So if initially they have the same number of nuclei, then the ratio of number of nuclei of X1 to that of X2 will be 1 by E after how much time? So we know that N is equal to N naught E to the power minus lambda T. So if I write it for, हमें पता लगाना है the number of nuclei of X1 to X2. So N1 is going to be N naught E to the power minus 10 lambda T, because it is 10 lambda, yeah. Similarly, N2 is N naught E to the power minus lambda T, because the second one has the decay constant as only lambda. Okay, so if we take the ratio of these two, they have the same initial number of nuclei. So N1 by N2 is equal to E to the power, if I take this up, I have minus 9 lambda T. Okay, question says that this ratio will become 1 upon E after how much time? So if I take this also as e to the power minus 1, I can say that 9 lambda t should be equal to 1, or minus 9 lambda t should be equal to minus 1, minus got cancelled. So t comes out to be 1 upon 9 lambda, very simply. Option D. Okay, easy one. Once again, awesome. Yes, correct answer is option D. Very well done, guys. Keep it up. Next one. A nucleus with mass number 220 initially at rest emits an alpha particle. So this basically will have mass number changing to 216 and 4. These are the two particles. One is an atom of an element and other is a alpha particle. These are the two particles which are coming out of it. That means more or less like a law of conservation of momentum will be applied. If Q value of the reaction is 5.5 mega electron volt, we have to calculate the kinetic energy of the alpha particle here. So very simply, the total energy of the reaction is 5.5 mega electron volt, and the kinetic energy of one of the particle is to be found. So what is given to us is that, one of the element is there whose mass number is 220. So what happens in this side, say an alpha particle goes, and on this side another atom goes whose mass number is going to be 216. This goes with a kinetic energy k1, or say this is k2 and this is k1. So we have to find out the value of the kinetic energy of your uh, alpha particle. So what is given to us is that K1 plus K2 is basically 5.5 mega electron volt. That is what has been mentioned. Okay, but we know that in this situation, the momentum of the two will remain same. And what is momentum? Momentum can be written as under root of 2 mk. So this is under root of 2 m1 k1 should be equal to under root of 2 m2 k2. Okay, that simply means under root, if I remove 2 and under root both will go. The mass of the first one is 216 m, its kinetic energy is k1. The mass of this thing is 4 m, kinetic energy is k2. So from here, what do I get? I get K1 or rather K2 I get as 54 times K1. When you simplify this, M gets cancelled. So 4 5s are 20, 4 4s are 16. So 54 K1 is what we are getting. Let's put it here. I get K1 plus K2, which means 55 K1 comes out to be 5.5 mega electron volt. That means K1 comes out to be 5.5 by 55, or simply 1 by 10, or 0.1 mega electron volt. Yes or no? So which means what? From here, K2 will come out to be 5.4 mega electron volt. Yes, that means the correct answer is option B. I hope you understood. This is more or less like a collision question, or the type of question that you solved in the chapter of center of mass and collision. Yes. Awesome, guys. Now tell me this one. In a radioactive decay chain, the initial nucleus is thorium. At the end of 6 alpha particles emission and 4 beta particles which are being emitted, if the nucleus left is this, then what is the value of A and Z? So from 232 thorium 90, there will be emission of 6 alpha particles. So 6 He, 4 and 2. So if 24 will go, then you will have 208 here first of all. Okay, say this is some Y because this is X, and this is 6 2s are 12, so that is 78, and from 208 Y 78, what you will have is 4 beta particles, 4e minus 1 0 plus. That means you will have to add 4 electrons here. So 208 x 82. Yes, option C is the correct answer here. Okay, you can see that 208 and 82. Very well, guys. Awesome. Now this one, the activity of a radioactive substance falls from 700 per second to 500 per second in 30 minutes. So its half-life is close to how much? So guys, we know that n by n naught, ये formula मैंने बताया था, is 1 upon 2 to the power t by capital T. We have to find out capital T. So n value is 500, n naught is 700, and this is 1 upon 2 to the power 30 by capital T. So this value is basically 5 by 7 here. Okay, that means we can say that 7 by 5 will be equal to 2 to the power 30 by T, and now let's take log, and 7 by 5 is basically 1.4. So 30 by T ln 2 is equal to ln 1.4. So T comes out to be 30 ln 2 by ln 1.4. Okay, so when you simplify this, guys, by using log table, obviously in JEE, obviously if this question comes, ln 1.4 value will be given to you. This comes out to be 62 minutes, nearly 61.8 this comes out to be. Okay, okay, the answer is option B, 62 minutes. Option B it is. Yep. So if they don't give the value, then obviously such thing will not happen. Ln value has to be given because they don't give you the log table. In JEE or NEET, if any question comes like this, they have to provide you the value of ln 1.4. Always and always. On the first page of the paper only, they give you these values. So don't worry. Okay. Now this one guys, half-life of two radioactive elements A and B are 20 minutes and 40 minutes. So initial sample have equal number of nuclei. After 80 minutes, the ratio of decayed number of A and B will be how much? Okay, we have to find out the value of Na by Nb here. So we'll go by the same approach again. So n by n naught is 1 upon 2 to the power t by capital T. So if I write it for Na by n naught, they have the same number of initial undecayed nuclei, that is 1 upon 2, 80 by 20, that's its half-life. So this comes out to be 1 upon 2 to the power 4, which is 1 upon 16. Okay, that means n naught is 16 Na. Similarly, if I, this is for A, if I do the same for B here, Nb will be N naught will be 1 upon 2 to the power 80 by 40. Its half-life is 40, second one. Okay, so this is 1 upon 2 to the power 2 or simply 1 upon 4. So N naught here comes out to be 4 times of Nb. So if I equate these two guys, equation number 1 and equation number 2, इन दोनों को equate कर देता हूँ. So I get 16 Na equal to 4 Nb. That means Na by Nb is 4 by 16 or simply 1 is to 4. Yep, 1 is to 4. That is option A. Very well. Awesome guys. Okay people, let's move on to semiconductors now. Let's have a look at the important formulas that you may need to know or important concepts. So if there is an intrinsic semiconductor, which is a pure semiconductor, number of electrons and number of holes are equal there, which we call as the intrinsic concentration also. Extrinsic, which is also mean impure, this means pure. So here the ratio of multiplication of Ne into Nh, obviously they are not equal depending upon p-type and n-type semiconductor. Ne or Nh will be variable, but Ne into Nh will be equal to Ni square. Okay, and in any transistor, remember that the emitter current will be equal to base current plus collector current. Okay, similarly for common base configuration of a transistor, the input resistance, output resistance, remember the amplification factor, current gain is delta IC by delta IE, okay, because it's a common base amplifier. Okay, similarly for common emitter configuration, people, don't worry, the session PDF will be available in the description also. Input resistance, output resistance, importantly the amplification factor or current gain is delta IC by IB. Remember, in both the current gains you have numerator as delta IC, collector current, and denominator accordingly, if this is common base it will be IE, if it is common emitter it will be IB. Okay, also if you can guys, please memorize this, the relation between alpha and beta. Beta is alpha upon 1 minus alpha. Okay, similarly for logic gates, please remember the truth table, and more than that, remember the Boolean algebra. So if this is AND gate, it's like multiplication. If it is OR gate, it's like addition. Inverter, or you can say the NOT gate, is also called as NOT gate. It just changes the value from 0 to 1 or 1 to 0. Similarly, NAND gate will change the AND gate output, make it dash. Similarly, NOR gate. Okay, A plus B bar. Similarly, XOR and exclusive NOR, these are not very important, but what are important are NOR gate, NAND gate, NOT gate, OR gate, and AND gate. Okay. Okay, guys. Now, first question: the density of electrons and holes in a pure germanium sample at room temperature is given to us. So this is basically the intrinsic concentration. This is Ni given to us. And on doping with aluminium, the hole density increases to this. So this is NH. We have to find out the electron density. So if you remember, we just now saw this formula. this one, Ne into NH equal to Ni square. Let's do that. Ne will be equal to Ni square by NH. So Ni square is going to be 9 into 10 to the power 32 divided by NH, that is 4.5 into 10 to the power 22. So this cancels 2 times into 10 to the power 10 per meter cube. Very simple. That is option C. Okay, no, not option C. This is option B. Option A. My mistake, guys. Option A is the correct answer. 2 into 10 to the power 10 is the correct answer. Tell me this, guys. Which of these is the forward biased connection for diode? Quickly, guys. Which one do you think is forward biased? फॉरवर्ड बायस कनेक्शन वो होता है जब ये V1 है और ये V2 है, so V1 should be greater than V2 for this type of diode. You can see that नीचे से शुरू करते हैं, ये लोअर पोटेंशियल है, ये हायर पोटेंशियल है, तो ये तो रिवर्स बायस्ड है. सिमिलरली ये लोअर पोटेंशियल है, ये हायर पोटेंशियल है, रिवर्स बायस्ड है. ये तो इक्वल पोटेंशियल है, तो यहाँ तो कुछ कंडक्शन वैसे ही नहीं हो सकता. सो दिस वन इज योर फॉरवर्ड बायस्ड केस. Very nice. Okay, now this one. So we have a circuit given to us in which when the diode is forward biased, the resistance is 50 ohms and with infinite backward resistance. So if the battery is 6 volts and the current through 100 ohm resistance is to be found. तो इसके through कितना current pass होगा वो पता लगाना है. So you can see that if current starts like this and goes here, so this will be forward biased and this will be reverse biased simply. So you will simply have to remove this branch. Just remove this branch, and because it is forward biased, so it will have 50 ohms resistance. So you can make it a resistance of 50 ohm value. So what you see here, guys, now you have a circuit like this. This is the kind of circuit that we are dealing with. This is 50, this is 150, and this is 100, and I value is to be found. This is 6 volt. So total resistance R equivalent is basically 50 plus 150 plus 100, which is 200 plus 100, that is 300 ohms. That's your resistance. So current value कितना हो जाएगा? E by EMF by R equivalent, which is 6 divided by 300, or simply 2 by 100, or simply 0.02 amperes. Option B. Very nice. Good, guys, good. Very well, very well. Yes, that's the correct answer. Keep it up. Now this one, guys, what is given to us is the value of the emitter current is 1 milliampere. Okay, the change in the emitter current, that means delta IC is given, delta IE, when the emitter current of delta IE is given and its collector current changes by 0.990, so this is delta IC. So we have to find out the current gain in the common base circuit. Okay, so in the common base circuit, I have already told you people that the value of current gain will always have delta IC in numerator, and because it is common base, so it will be delta IE in the denominator. Delta IC is 0.99, and this is okay, both are milliamperes only, so this is simply 1. So alpha is simply 0.990. So very simply we got the answer as option D. No, we only have to find out the value of current gain, no? So answer is option D. Okay. Okay, try this one then. The current gain of transistor in common base mode is 0.99. That means the value of alpha has been given to us. If the change in emitter current is 5 milliampere, then the change in collector current will be how much? So alpha is delta IC by delta IE, and delta IC पता लगाना है. So So that is alpha into delta IE. So alpha is given to you as 0.99 into 5. So obviously the value is less than 5 here. Simplify this, you will get the answer as 4.95 milliampere. You can multiply that very easily. Okay, answer is option A. Very good, guys. Awesome. How about this one? What is the beta value for transistor whose alpha is given to you as this? I told you people relation between beta and alpha is to be kept in mind. So beta is alpha upon 1 minus alpha. So if alpha is 0.98 divided by 1 minus 0.98, so that value is 0.98 divided by 0.02, or simply 98 by 2, which means 49. Okay, yes, correct answer is option C. Very good, guys, keep it up. Now this one, if alpha and beta are current gains in the common base and common emitter configuration respectively of the transistor, then we have to find out the value of beta minus alpha upon alpha beta. Okay, so we know that we have to find out the value of beta minus alpha upon alpha beta. ये पता लगाना है, तो पहले न्यूमरेटर और डिनोमिनेटर सेपरेटली पता लगा लेते हैं. So beta is basically alpha upon 1 minus alpha. तो एक काम करते हैं, इसे अल्फा से मल्टीप्लाई कर लेते हैं दोनों तरफ. सो आई हैव अल्फा स्क्वायर अपॉन 1 माइनस अल्फा. सो डिनोमिनेटर तो सॉल्व हो गया. नाउ फॉर बीटा माइनस अल्फा, बीटा इज अल्फा अपॉन 1 minus alpha minus alpha. So this comes out to be alpha. Why this is written? This is beta and this is alpha. So this is alpha minus alpha plus alpha square divided by 1 minus alpha. This gets cancelled. So beta minus alpha comes out to be alpha square upon 1 minus alpha. So we have the 2 now. So therefore beta minus alpha upon alpha beta is equal to alpha square upon 1 minus alpha into alpha square upon 1 minus alpha, which simply means the ratio is 1 here. Yes, yes, yes. Awesome, guys. Very well. Correct answer is option B. Very good. Okay, now this one, the combination of gates shown here are equivalent to which one? पता लगाना है हमें. So you know that if this is A and this is B, this basically is a NAND gate. These two are NAND gate. All three are NAND gate. This one, everything is a NAND gate here. Okay, let's try to simplify this, guys. So if this is A, the output is going to be A bar. If this is B, the output is going to be B bar, because only input is A and A. So the output that you are getting is A bar. So A bar and B bar are being fed as the input. So AND gate it is. So that's why A bar into B bar was supposed to be the output. But what is happening here? There is a NOT gate also there. So C is equal to A bar into B bar, the whole bar. But as per the De Morgan's law, if we have A, B bar, then that becomes A bar plus B bar. That means what? This will become A into B, or you can say A bar bar and B the double bar, which is basically A into B. So the first one is basically your AND gate. Sorry, this should be plus here, no? From here, it should be plus. So this is basically an OR gate. What do you think, guys? Not able to read the chart here. Yes, it will be A plus, correct. A plus B. So it's an OR gate. Similarly, here, if it is A and B, the output was supposed to be A into B, but there is a NOT gate, so A into B bar, that you will feed. So what you are going to get eventually for C is the multiplication of A into B, the bar, multiplies with A into B bar and the whole bar because there is a NOT gate. So same thing we apply again. So we have A, B bar, the whole bar, plus what we get eventually is this. And this, we should know that X double bar is basically X. So this is AB plus AB, which is basically AB. Or you can say this is also nothing but AND gate. Okay. You can also try this with the truth table, guys. So what we are getting that this is an OR gate, this is an AND gate, or AND gate. That means option A. Okay. Okay. How about this one, guys? Can you tell me this quickly? Which of the logic gates it is representing? So 1 and 1 are the input and the output is 0. 1 and 1 are the input and output is 0. So surely it is neither OR gate, it is nor AND gate. Why? Because for OR gate and AND gate, for 1 and 1, the output has to be 1. So या तो आंसर NOR gate होने वाला है या NAND gate होने वाला है. So next one, it is 0. This is also 0. And what we are getting is 1. So if 0 and 0 was supposed to be 0 for an OR gate, then it will become 1. 0 and 0 remain 0 for both. So अभी भी clarity नहीं है. Third वाले पे आते हैं यहाँ पे. This is 0. This is 1. 0 and 1 in an OR gate become 1. In a AND gate, it become 0. So if it is a NOR gate, the output will be 0. If it is a NAND gate, the output will become 1 and the output is 1, which simply means that the answer is NAND gate. Correct answer is NAND gate. Very nice, guys. Very nice. Okay. How about this one? So we have this A. So here what we are getting is A bar. B becomes B bar. We are feeding it to NOR gate. So first of all, A bar plus B bar and the whole bar here. That means it will be A double bar into B double bar by the De Morgan's law, which is simply A into B. Or you can also try with the truth table. The correct answer is AND gate. Okay. Awesome. Awesome, guys. Keep it up. Homework question for all of you. Take a screenshot, everyone. Take a screenshot. You have to find out the correct truth table for this one. Okay. Taken the screenshot. Cool, guys. So this brings us to the end of the session. If you are interested in the crash course, you guys can still join because your JEE examination is going to happen towards the May end 2020, or maybe after that, we don't know that. So you have a lot of time. You have roughly 2 months. So if you want to further seriously prepare for your JEE preparation, crash course is there. Okay, how you can enroll? All you have to do is use this link which is available in the description of the video. Don't forget to use this coupon code, because with the coupon code, the course which is worth rupees 30,000 can be yours for just rupees 2,900. Okay, guys. Cool. So I hope you guys enjoyed the session of modern physics with me. If you did, then do hit that like button over there. Tell your friends if they are still not here. Share with your friends. Let them also come. The class will be fun. Okay, just like the way you guys do the video callings. Okay, and if you have not done it yet, guys, do subscribe to the channel. Okay, so don't worry. I know the sprint session has almost come to an end here, but don't worry. As I told you, classes don't end. We will continue teaching. We will continue motivating you people, because we have ample time still left with you. We are under process of planning sprint 3.0 and we'll be back with that. Okay. Thank you, Asta. Thank you so much. Thank you everybody for coming here. I had an awesome time. Thank you so much for coming live, because in the day when there is actually nothing to go out and do, we can't go out, we are all house arrested. This feels like I'm interacting with people and I'm sure you guys are feeling the same way. And in this process, we are learning, and I'm able to teach. That's what I love to do. Okay, guys. Okay, so yes, I'll see you all again very soon. Yes, we'll be solving MCQs of this tomorrow at 6 p.m. So don't worry, I'll be back again with more questions on this chapter. Till then, you can revise this once again, try to solve the questions by yourself, especially the questions where I didn't do the calculations much. Do the calculations by yourself, solve it. And if you have solved the homework questions, do post the answer in the comment section. I'll respond with the correct answer. Okay, guys. So I'll see you again soon. In fact, tomorrow. Till then, take care, keep smiling, stay home, stay safe. Bye bye.